Yes, sir.
Yeah. Am I audible to you, Darnell?
Yes, sir.
Okay. So you have doubts?
So none so far.
Okay. So should we do few questions from whatever we have done till now?
So we can do from AOD.
Okay, from AOD. Fine. So there is a question. It says X and Y are the sides of two squares. Are the sides of two squares such that y equal to x minus x square. Find the rate of change of the area. Find the rate of change of the area of second square with respect to the area of first square. Of second square with respect to the area of first square. Okay. Do this question while I am writing second question. Next question says, at what point the slope of the curve y equal to minus x cube plus 3x square plus 9x minus 27 is maximum. Also find the maximum slope. So first try these two questions and we'll do more of them. Giving you the third question also. Third question says AB is a diameter of a circle. AB is a diameter AB is a diameter of a circle and C is any point on the circle. C is any point on the circle. Show that the area of triangle ABC is maximum when it is isosceles. These three questions are there. Are you doing? Have you started doing?
Yes, sir. Oh, so I'm not sure to do the third question.
Okay, so what are you getting the answer for first one and second one?
Oh, so first one I got 2x square minus 3x plus 1.
2x square
And
minus 3x plus 1. This is what you're getting?
oh, yes, so
1 second, let me check. So area of the first one is x square and area of the second one is y square, right? And then you are doing d of by d of a1. So d of y square by d of x square you are doing. So now d of x square you are doing fine. So d of y square with respect to dx, dA of x square with respect to x. So it will be 2y dy by dx, and here it will be 2x. So 2 cancel and you will get y by x dy by dx. Now what is dy by dx? If you see 1 minus 2x, okay. And what is y? X minus x square. So x will cancel and 1 minus x into 1 minus 2x you will get. So you will get 2x square minus 3x and plus 1. Yeah, fine. So first one is okay. And what point the slope of the curve is maximum? Also find the maximum slope.
so I got x is equal to 1 and maximum is 12.
Maximum slope is 12 and you're getting x is equal to 1. Okay, let us see. So at what point the slope of the curve is maximum? So we will have to find maxima, minima, and we'll differentiate it and equate it to 0. And we will do that, we'll get minus 3x square plus 6x plus 9 is equal to 0. So minus x square plus 2x plus 3 is equal to 0. From here you will get minus x uh, minus you will common minus 2x minus 3 plus 3 into x minus 1 equal to 0. So it will be minus x square. So this will become minus, this will become plus. X square plus 2x and plus 3. So it is fine. So you will get x is equal to 3 and minus 1. So x is equal to 3 and minus 1 are two values. Now you are saying 1. So 1 is not coming anyhow. Either it will be x is equal to 3 or x is equal to minus 1, right? So we have to check for these two. Now how do we check for these two? You can do the first derivative test and see that how the sign of this first derivative, this is the first derivative, it is changing. So it is 3 and this is minus 1. It will be negative here as there is a minus sign, positive here, then negative here. So this is the sign scheme of first derivative. Now in the final sign scheme of first derivative, what you have to observe that for maxima, the derivative should be changing from positive to negative, and in minima it negative to positive. So positive to negative it is changing at 3. At that minus 1 it is negative to positive. So this will be the minima and this will be the maxima. So 3 is the maxima and minus 1 is the minima. This is the maxima and this is the minima. If they are asking for maxima, then your point of maxima is x is equal to 3 and maximum slope is equal to, when you will put x is equal to 3 here, Oh, sorry. I've done a small mistake here. I'm taking the maxima of the y. We don't have to take maxima of the y. We have to take maxima of the dy by dx. So again, this is a question which is one level further. So we have to do with these calculations are fine. I hope you understood now what I did wrong here.
Yes.
No, what I was taking is to find maxima or minima of the function. And we have to find maxima or minima of the slope. So first we find slope. This is the slope, which is, you can take this one also, and then differentiate slope. It will be minus 2x plus 2. So x is equal to 1. So yeah, x is equal to 1 is fine. So x is equal to 1 is the probable value where there could be a maxima or minima. Now, if we see about x is equal to 1, this is minus 2x minus 1, how the sign is changing. So 1 is here, only one critical point. So here it is negative, here it is positive. So the sign scheme of dm by dx is, this is actually d2y by dx. This is nothing else but d2y by dx. So this value is changing from positive to negative. So yes, it is a maximum, correct. So in that case, the value of the slope will be minus 1 minus 3 into 1 plus 1. So it will be, now this value I think you have not got correct, because this will become 4. So maximum value of the slope will be 4. Let me check the answer.
So I did double differentiation. So for the minus 3x squared plus 6x plus 9, then I did, instead of dy by dx, I did d square y dx squared. So it'll be minus 6x plus 6.
Yeah, that is fine.
So then it'll be minus 6 outside x minus 1 and x equal to 1, right?
I changed it. Oh, sorry. Earlier I took minus 3 common, and that I kept like that. It was equal to 0, now then it changed. So it will be 12. Sorry, my mistake. 3 outside also. So it is 12. Yeah, I earlier I was taking it equal to 0 now. So I took that 3
Yes.
inside to 0. I kept that as it is. Okay. Third one, have you tried? No.
So no, I wasn't able to.
AB is a diameter of a circle. Let's see any point on the circle. Show that area of triangle ABC is maximum when it is isosceles. So if you take a circle and you say that there is a diameter of the circle AB and it is passing through the center, then there can be point on the circumference, many point on the circumference. Suppose you can take C1, you can take C2, you can take C3, many points are possible. So out of all these triangles which are getting formed, it is being said that the triangle which is isosceles is having the maximum area. Fine. So even if you don't know differentiation, you can do this question. But let us first talk about differentiation. So if this AB is a diameter, I'm taking this circle as having the AB as the x-axis and O as the center and this as y-axis. And this equation of the circle will be x square plus y square is equal to a square, which is its radius. So y is equal to root over a square minus x square we can take. Also, we can take y is equal to minus root over a square minus x square. So if minus a square minus x square we can take, that means we are talking about the below semicircle. If we are taking plus root over a square plus x square, that means we are talking the above semicircle. So any one we can take. So I'm taking above one. Okay, the point on the above one And similarly, the point in the lower one gives you the symmetric result. So if you take it like this and take a point C1, so this is minus a comma 0. This is a comma 0 because this is the radius a, which is a constant. C1 is a variable point and I'm taking it as x on the circle, and y is root over a square minus x square on the circle. So if you take the height, so from any point C, the height would be perpendicular length, and that height will be equal to root over a square minus x square. This are you are getting, I hope. In this circle, now, this is a diameter, and this is a semicircle like this. We're taking a point here. So its height will be root over a square minus x square, which is y of that point. Can we take it like this?
So I've been logged out for the past 5 minutes, so I didn't understand the first explanation.
Okay, you were logged out.
No, yes, sir.
Okay. Okay, I'm explaining it again. So from beginning you haven't understood or in between somewhere?
No, so from the start.
Okay. So we have this circle whose radius is a. So x square plus y square is equal to a square. For simplicity, we are taking it like this. O is the center of the circle. Y dash is the y-axis, x-axis is x-axis. AB is the diameter. So B is a comma 0 and A is minus a comma 0. I'm taking in general any point here on the semicircle C, which is x comma y. So since this is the equation, y can be taken as root over a square minus x square. Like this. So this perpendicular one is actually the y coordinate. This is the height. Are you getting this?
Yes, sir.
So when you make the triangle like this is the height of the triangle from the base. Now area of this triangle will be ABC is equal to half into base is 2a, that is the diameter, and height is root over a square minus x square. So this is the area. So a root over a square minus x square. Now this area needs to be maximum. So for that you will differentiate this area dA by dx. So a will be outside by 2 root over a square minus x square, and a square minus x square will be 0 minus 2x, like this. We do the chain rule. So this will be 2 cancel minus ax by root over a square minus x square. This is what we will get. Now derivative of area with respect to x is minus ax by root over a square minus x square. Now when this needs to be maximum or minimum, this should be 0 or undefined for the critical point, right?
Mm.
So it can be 0 at x is equal to 0 and undefined at x is equal to plus minus a. So this is for 0, this is for undefined. Now you can easily see if you take the C point at plus minus a, but if you take point either here or here, the triangle is not possible because C will overlap with A or B. So third point, which is 0, is here. So this will be the triangle. So this is an isosceles triangle. So you will say that x is equal to 0 is the point where maximum area is possible. Whereas plus minus a are the points where minimum area is there. Minimum area means 0 area. Triangle is not possible. Area is equal to 0. No triangle possible. So we can say triangle of zero area. So this means it is an isosceles triangle. So this is one way of doing it. But there is another way of doing it, which is very, very simple. What that means, what is that step is, this you have noted down.
Yes, sir.
So other one says that if you have a circle and you are fixing the diameter AB, then the triangle would be this way, this way, this way. And geometrically, if you see the height of these triangles, so this could be the height, this could be the height, this could be the height, so on. So what is the area? Area is half into base into height. So here only thing which is varying is height, not the base. Base you are taking as 2a, which is constant. And the height is varying. This is variable. So clearly from geometry, you can see where do you get the maximum height? When this C point is here, that is giving you the maximum height. At other places, the height are less than that. So this is the point where you will get the maximum area. So you can just say like that from geometry also. Is it okay?
Yes, sir.
Just come to the next question. The sum of the surface areas of a rectangular parapet with sides x, 2x, and x by 3 and a sphere is given to be constant. To be constant. Prove that the sum of their volumes is minimum. If x is equal to 3 times the radius of the sphere, if x is equal to 3 times radius of the sphere, also find the minimum value of the sum of their values. Also find the minimum value of the sum of their volumes. Just try this. I'm coming in 2-3 minutes.
So what's after the word of rectangular?
Parallelopiped. Just as it is a parallelogram, na? So in 3-dimensional figure, which is a parallelopiped. Like a
Okay, sir.
cuboid. Cuboid is like rectangle. So parallelopiped is like a parallelogram. Okay.
Yes, sir.
Yes, Darnell. Anything to ask?
Oh, so I'm not able to do this.
Sorry.
So I'm not able to do.
Okay. Okay, so I will give some initial steps and let's see whether you will be able to follow and you will be able to think about the further steps. So it is saying the sum of the surface areas of a rectangular parallelepiped with sides this, and this. So the parallelepiped which can be drawn is, suppose this is the base and this is like this. This is the parallelepiped. I'll have to draw. This is small space. I'll have to draw it below. Okay, this is a parallelepiped. Its sides are given that x, 2x, and x by 3. So this is x, maybe this is 2x, maybe this is x by 3, maybe. So these three dimensions are given. And a sphere is given to be constant. A sphere is this one. Its radius can be taken as r. So the sum of the surface areas of a rectangular parallelepiped with these sides and a sphere is given to be constant. Okay. So what is the surface area of a parallelepiped? Uh, it must be a rectangular parallelepiped. That means the base is rectangular. So we can take is as 2x into x 2 times plus x into x by 3 2 times plus 2x into x by 3 2 times. So there is a ceiling and a floor, then two opposite walls, and then two opposite walls. So this is how you will find the area of the parallelepiped. Area of the circle sphere is 4 pi r square. So this is constant. This capital A is given to be constant. It is not a variable. Prove that the sum of their volume is minimum if x is equal to 3 times radius of the sphere. Sum of their volume. So volume of the sphere is 4 by 3 pi r cube. And volume of the rectangular parallelepiped is x into 2x is the base. And if we take the height as h, yeah, volume of the parallelepiped is this 1 by 6 LBH. No, it is actually not 1 by 6. That is the scalar product. So why can't we take it as a rectangular, as a cuboid? So if it is x into 2x into x by 3, like this is the volume. Let us see taking it like this. So this volume is minimum. This we have to prove if x is equal to 3r. This to prove. So we are taking it as a cuboid only. Also find the minimum volume value of the sum of their volumes. So what we need to do here is 4x square plus 2 by 3x square plus 4 by 3x square. So 2 by 3 plus 4 by 3 is 6 by 3, 2x square plus 4x square, 6x square. plus 4 pi r square. So from here we get a like this. From here we can write r as a minus 6x square. Are you there, na?
Yes.
Okay. A minus 6x square by 4 pi square root. This is r. Now in this volume, we put 4 by 3 pi r cube. That will become a minus 6x square by 4 pi to the power 3 by 2 plus, and another term is 2 by 3 x cube. So this is the volume. Now this volume is minimum. So what we have to do is, first let us write it like this. This is 4 pi to the power 3 by 2, and this is 4 pi. So this will be 1 by 3, 4 pi to the power 1 by 2, and this is a minus 6x square to the power 3 by 2 plus 2 by 3 x cube. So this volume is minimum. dv by dx is equal to 0 we do. So when we do this, 1 by 3, 4 pi to the power 1 by 2, and 3 by 2 a minus 6x square to the power 1 by 2 into minus 12x we will get plus 2x square we will get, and we equate it to 0. So in the next step, okay, this is fine. Pi is also coming now. When you equate to 0, you'll get x. Fine. So this will become 3 cancels. 2 6 12. So minus 6 by 4 root over 4 pi x into root over a minus 6x square, and this is equal to 2x square. You can cancel x, and you can again square it. 4 pi into 4x square, it will become equal to 36a minus 216x square. So this calculation we are doing here. So what you get is 16 pi plus 216 into x square is equal to 36a. So x square will be 6a. Okay, it is 36a by 16 pi plus 216 and a square root of this. So that will be x. Now, if you find out r, it is this a minus 6x square by 4 pi under root. So it is r is equal to a minus 6x square. So 6 into 36a by 16 pi plus 216. Are you following?
Yes.
By 4 pi under root. A little lengthy question is it. So this would become 16 pi a minus 6 into 36 is again 216. That will get cancelled on 4 pi under root into 16 pi plus 216. So this will become 4a by 16 pi plus 216 square root. Now, if you compare x and r, x is this and r is this. So if you compare them, you can say x is equal to 36 can be written as 9 into 4, and 9 can become 3 outside, and it will become root over 4a by 16 pi plus 216. So this is 3 times of, this is r. So x is equal to 3. This is the first thing which we prove. Is it okay?
Yes, sir.
Okay. Next, what we do is also find the minimum value of the sum of their volume. Minimum value of the sum of their volumes. So what was the sum of their volume? It was this 4 by 3 pi r cube plus 2 by 3 x cube. So 4 by 3 pi r cube plus 2 by 3 x cube. It will become 4 by 3 pi r cube will be 4a by 16 pi. This is calculation now. 4a by 16 pi plus 216 under root. So this will be 3 by 2 plus 2 by 3 x cube will be, in fact, 9 r cube. So r cube is again the same thing. So 3 by 2, 4a by 16 pi plus 216. So this would become 18 4 pi plus 18 by 3 into 4a by 16 pi plus 216 to the power 3 by 2. This you can write as the final answer. Let me check also. So one part is the proving part. Another one is the answer of this. So it is k to the power 3 by 2. That is a to the power 3 by 2. That is fine. By 3. Yeah, that is also fine. And 16 4 pi plus 54. So, okay, 4 pi to take common. And if you will see the value here, 4, 5, 20, 54. 4 into pi plus 54. That is fine. In numerator, we are not getting the same thing. No? There is slight difference between our answer and their answer. That is a very small difference. If we get this value as 54, we will have the same answer. This value they are getting as 54. They have simplified this after that. This value is 54. So have we done any mistake here? 4 pi plus 18 by 3. What was 2 by 3 x cube? This one, no? It was 2 by 3 x cube, and x is oh. So x cube is 3r cube. So when you will do the cube of 3, it will not be 9, it will be 27. So this will become 4 pi plus this careless mistake we did. So in the next step, it will be 4 plus 50. Have you got the mistake? Hello?
Yes,
Yes,
sir.
Darnell? That is 27,
Yes,
but
sir.
not 9. So 4 pi plus, okay, 4 pi plus 54 to the power 3 by 2 by 3 this is. And when they will write the final answer, 4 cancels. It is a by 3, a to the power 3 by 2 by 3. And this 4 pi plus 54 to the power 3 by 2 and 4 pi plus 54 will give you the resultant value as 4 pi plus 54 to the power 1 by 2.